entity we're going to talk is the arc, which is really a subset of a circle, and there are many options for creating arcs. And actually, you get prompts below here in this area. I've minimized the screen to made the screen a little bit smaller to make my recording smaller, but you can get prompts here. But the most common entity when you're using an arc is the 2-point arc here, which really makes it, you select a center and a radius and it will give you the arc. Likewise, there are 3-point circles, 3-point arcs. That means you can go and create an arc, and this point has a drop point, so you can control the angle of the arc and you can also calculate the length of the arc using the built-in function. That's the default length. And please keep in mind that the arcs are drawn counterclockwise, but if you make an error, you can simply flip the arc and you'll get the polarity that you want. So quite often it is necessary to constrain the arc with respect to another geometry. So let's take a couple of examples of that. Let's say I have two lines here, they're intersecting, and I want to create some kind of a fillet here. So I will take the 3-point arc, constrain it to be tangent to this, then a point where this will pass for the radius, and third point is tangent to this. And then I can just trim this line, double click on the point to get the drop point and say this is at the end of the arc, and likewise double click on this and say this is at the end of this arc. So now you'll see the arc behaving. Let's take another example. Let's say I want to create a belt drive. So I have two pulleys and I'm going to pass a belt over this. So first I take the line tool and I double click on the circle, on the tangent constraint, click on this and click on this one, and once again, and I can infer this point. Then I'll take the circle tool, take the arc tool, I'm sorry, and I'm going to use this option which is center point point. So the center of the arc is constrained to the center of the circle. One end of the arc is constrained to the end point of this, the other one is constrained to the end point of this. And likewise, I'll take the center here, constrain it to the end point here, and end point here. Then I can press the shift key and click on the 4 entities. Let's give it a style, let's say, and let's give it a color. So there's your belt. And if you want to know what's the wrap angles, you just say from the here to here and here to here, and you can then put an angle dimension here and that'll give you the wrap angle. And if this thing changes, the wrap angle is changing. You can calculate the length of the belt, very simple. Just click on the line, plus the length of this line, and plus the length of the last arc. And now if I change the geometry, you see the arcs are constrained and they are modifying. Sometimes you need to create a profile involving arcs, and it's easier to constrain the arc with respect to another geometry, and that's where you have full control. So I'll do a fun exercise here. I'm going to make a circle and I'm going to make a circle inside this. Then I will draw a line here to here, and then I draw a line from here to here. And I want to find what's the area of this segment here. So what I'll do is take the arc tool, center it here, from the intersection here to intersection here, and from the center again at the end point of the line, and this intersection to this intersection. Then I'll constrain two lines from the end point of the arc to the endpoint of this arc, and the other line is from the endpoint of this arc to the endpoint of this arc. So now I have the basic profile. Press the shift key and select the elements and define area, and I can calculate the area, for example. And so now if this thing changes, the area is updating. So let's say I have a specific target for that area. Let me say 170 millimeter to the power of 2 millimeter square. So I can back solve the angle of this line to give my goal. This is the actual value to target value by changing the angle. So the constraint arc now will be animating. So if I change the radius of this circle, you notice that this line is automatically adjusting. I can even put a measurement on for the angle here. Click on the line, substitute and say angle, and this is so as I'm changing my targets, the angle will update. So with a little imagination and understanding of the tool, you can make pretty complex function models very quickly and easily using the circles and the arcs and the lines, and get your answers to make sure that you're eliminating any guesswork or trial and error and getting the precise answers. Thank you.